From quantum science, we know that to solve the Schrödinger equation for valence electrons, we should know the potential. Valence electrons experience a Coulomb potential due to nucleus with this form, and also Coulomb potential due to tightly bound core electrons. Pseudo-potential replaces the strong Coulomb potential of the nucleus and tightly bound core electrons with an effective ionic potential that acting on the valence electrons. In this figure, we have two cases. In one case, on the left side, we consider core electrons and nucleus. We can see the potential. In this case, this is a dashed blue curve. In the second case, we consider only pseudo-potential, as you can see, as the red curves. The point is that in both cases, the wave function after RC is identical. After RC, both blue and red curves are coincidence. Because our focus is on valence electrons and the wave function of valence electrons obtained identical, we use pseudo-potential instead of nucleus potential plus core electron potential. Indeed, Schrödinger's solution, by considering nuclear potential plus all of electron potentials, is so hard to be solved computationally. We can get pseudo-potential files from Quantum Espresso webpage. This is Quantum Espresso webpage. We choose the pseudo-potential tab, and then we can see periodic table. We choose the element we want, for example, carbon. We can see that there are many files to choose. We have many options according to the type of pseudo-potential and exchange correlation function. For example, we can choose this one. This is the pseudo-potential file we choose. As we can see, the first part defines the exchange correlation function. In this example, it is PBE. PBE is an abbreviation of Perdo-Bark-Nusa and its type is GGA. GGA is an abbreviation of Generalized Gradient Approximation. Another exchange correlation type is LDA, that is abbreviation of Local Density Approximation. Local density approximation is the case that exchange correlation energy depends only on the density at points. This exchange correlation is insufficiently accurate, but GGA uses both the density and its gradient at each point. GGA is more accurate than LDA. Second part of pseudo-potential defines the type of pseudization. Indeed, introduce the method used to produce pseudo-potential from nucleus potential plus core electron potential. If we open the pseudo-potential file with a notepad or similar software, we can see this text file. We can give important information about this type of file. For example, we can see pseudo-potential type, that is US, means ultrasoft. Also, the functional type, that is PBE, the element, that is carbon. And also, it considers 2s and 2b carbon orbitals. This is the self-consistent field flowchart. We will describe this self-consistent field flowchart in the next lectures. And effective potential is the summation of effective ionic potential plus Hartree potential plus exchange correlation potential. Thus, the effective potential depends on the pseudo-potential we use. Also, we should introduce the pseudo-potential file in Quantum Espresso input file. In the Quantum Espresso input file, we should define in order the name of the element, that is C, the mass of element, and the pseudo-potential name here. Also, we should specify the directory that the pseudo-potential file